Imagine stepping back, way back, maybe thousands of years. You close your eyes, and you can almost hear the crackle of a fire, maybe whispers of ancient people gathered close.
Hmm.
The air is filled with this distinct scent of smoke, right? Mingling with the earth. And they're passing around this beautifully crafted pipe.
Yeah, a common scene we imagine, definitely.
For centuries, archaeologists, they've unearthed countless pipes like these. They hint at really profound cultural practices. But here's the question that's kind of baffled everyone.
Yeah,
What exactly were they smoking?
right.
And how, after all this time, could we possibly figure that out?
It really is one of those persistent mysteries, isn't it? For so long, our understanding, it relied on, well, educated guesses, really,
Yeah.
often based on more recent history or, present-day practices.
So you find a pipe, you think tobacco. That's the easy assumption.
Almost a reflex, yeah. But those assumptions, well, okay, as a starting point, they left us with so many unanswered questions. There was this huge, blank space in our knowledge for thousands of years.
And that's exactly why we're diving in today. This isn't just about old artifacts, it's about a revolutionary leap in archaeological science. We're finally cracking that ancient smoke code.
Mm-hmm.
Our mission is to unpack this groundbreaking study. It gives us this unprecedented window into the deep time relationship between plants and people. And honestly, get ready for some surprising insights into ancient drug use, trade, culture, things we just didn't know.
Absolutely. We're going to be sifting through a really comprehensive paper published in Frontiers in Molecular Biosciences. It introduces this whole new way of looking at residues. They call it an ancient residue metabolomics-based method.
Okay, that sounds technical.
It does sound like a mouthful, yeah. But think of it like this. Instead of just guessing the main ingredient in an old dish, this method lets us read the entire detailed recipe, like molecule by molecule. It's a total game changer for understanding history.
I like that. So this is your shortcut, basically, to understanding how modern science is just lighting up our ancient past. You're going to have those real aha moments about how much we didn't know and what we're discovering now about our ancestors' lives.
It connects us directly to them in a way.
Totally. So let's get into this remarkable scientific detective story.
When we think about human history, it's easy to focus on, the big stuff, empires, wars, monuments.
Right, the grand narratives.
Exactly. But there's this other incredibly fascinating story, our long, really intimate coevolution with plants, especially plants with psychoactive or medicinal properties.
It's not just a modern thing, then. This goes way back.
Way, way back, rooted deep in our past, tied up with our development as a species.
It's captivating, isn't it? Humans seeking out specific plants, experimenting, understanding their effects, weaving them into their lives. But like you said, for ages, our understanding was mostly projection. We'd find a pipe, assume tobacco, based on recent history.
And that's the crux of the problem, really. That analogy approach, while necessary when we didn't have better tools, can be seriously misleading. It overlooks the sheer diversity and sophistication of ancient plant use.
Like judging ancient food just by what's in our supermarkets today.
Precisely. You'd miss so much. So how reliable are those assumptions about ancient practices if they're just based on a limited recent view?
That's a really good point. And it brings us to what the researchers call the biomarker bottleneck. The old way was looking for these individual signature chemicals, biomarkers.
Mm-hmm.
Find nicotine, okay, great, it's a Nicotiana species, tobacco, but that was often it.
Right. And while that was useful, a good first step, it had major limitations. Detecting nicotine only tells you it was some kind of Nicotiana. It couldn't tell you if it was a local, native species people cultivated for generations, or maybe a variety brought in through trade.
So huge gaps remained about local practices, cultivation, how these plants fit into daily life, rituals.
You just got the general category, none of the rich specific detail.
Okay, let me see if I got this. It's like finding an ancient cup, detecting caffeine, maybe.
Yeah.
So they drank something with caffeine, but was it like a rare local bean they treasured? Or was it a common trade commodity from halfway across the world? That missing detail changes everything about their diet, their trade, their economy.
It's a perfect analogy. It's all about that missing nuance. Besides nicotine, they looked for other things. Anabasine, arbutin, cotinine for smoke plants. For drinks, maybe theobromine, theophylline, caffeine, hinting at cacao, or yapon holly.
Yeah, right.
But as the paper clearly states, these methods failed to distinguish between related species. So, critical questions about how humans managed plants, domesticated them, traded them, moved them around, grew them, used them in rituals, they all remained frustratingly unanswered. One biomarker just wasn't enough.
And the scale of what we didn't know is just mind-boggling. The study points out that when Europeans first arrived, indigenous peoples in North America were smoking maybe as many as 100 different plant species.
100. It's staggering. Far beyond just tobacco. It hints at this incredibly rich, diverse ethnobotanical world we'd barely glimpsed.
So where did this study focus to try and tackle that huge number?
They focused specifically on the Pacific Northwest for their initial work. They gathered and studied common smoke plants known from that region, plants with strong historical accounts of being smoked.
Like what? What kind of plants are we talking about?
Well, things like Arctostaphylos uva ursi, that's bearberry or kinnikinnick, Corniceracea, the red osier dogwood, and of course various Nicotiana species, coyote tobacco and attenuata, Indian tobacco and quadrivalvis, Aztec tobacco and rustica, and the cultivated tobacco we know, Intabacum.
Okay.
Plus others like Rhus glabra, smooth sumac, and even Taxus brevifolia, the Pacific yew. Each one was a potential piece of this ancient puzzle.
And this really highlights what I think of as the pipe paradox. We find these incredibly old pipes, 4,000, 5,000 years old in the Pacific Northwest.
Ancient treasures.
Absolutely. But until this new method, we knew almost nothing about what was smoked in them before Euro-American trade tobacco arrived after the 1700s. That's a massive gap. Thousands of years of indigenous practices just unknown.
It is like finding that ancient car but having zero idea what fuel it used. You know, it was important, you know people used it, but the core substance, the thing that made it culturally significant, was a mystery.
It's like finding cooking pots and just knowing they cooked. But were they making simple local stew or some complex feast with rare traded spices? The ingredients changed the whole story.
Exactly. That lack of specific chemical data really limited our appreciation of just how sophisticated these ancient societies were.
Okay, so the old biomarker approach hit a wall. How did this new metabolomics approach just blast right through it? What's the secret sauce?
Right, so this is where metabolomics comes in. And the core idea is fundamentally different. It's not about finding one or two smoking gun chemicals.
No single biomarker.
No. Instead, it's a comprehensive study of all the metabolites, the multitude of small chemical compounds within a sample. In this case, the residues scraped, or rather extracted, from an artifact.
So not just a single fingerprint saying tobacco, but the plant's entire chemical profile, like its metabolic autobiography.
That's a great way to put it. As the researchers say, beyond biomarkers, a multitude of other compounds, mostly unknowns, are detected. It's about capturing the entire chemical fingerprint, even the subtle stuff.
And the so what of that is?
The so what is huge. This lets them do something impossible before, distinguish between even closely related species. And crucially, confidently, identify multiple plant species used in the same pipe, maybe mixed together, maybe smoked one after the other.
Wow. Okay, so you go from a tobacco to this specific native tobacco, maybe mixed with this other specific plant at this time.
Exactly that level of detail.
But these pipes are priceless, right? Some are really fragile. How do you do this deep chemical dive without damaging these ancient artifacts? You can't just scrape away at a 1,400-year-old pipe.
That's a critical point. Preservation is absolutely key. And the method they developed is brilliant because it's incredibly gentle, but also really effective. They use what's called a sequential extraction method. No physical damage, no scraping, no drilling.
So how does it work? Magic.
Almost. They basically give the pipe a series of gentle chemical baths. They submerge the artifacts sequentially in different solvent solutions.
Solvents, like cleaning fluids?
Not quite. There's specific chemical solutions designed to pull out different types of compounds. First, it goes into tartaric acid, TA. That's great for extracting alkaloids like nicotine.
Okay.
Then into a mix of acetonitrile, 2-propanol, and water APW. That gets a lot of the polar to medium non-polar stuff like flavonoids, phenolics, things related to flavor, color, maybe medicinal properties.
Right.
And finally, methyl tert butyl ether, MTBE. That targets the non-polar things like resins or waxes.
So they're basically coaxing out the chemical history with these different baths. Gently.
Precisely. Each time, they use gentle sonication, like tiny vibrations in a water bath for a set time. This dislodges the microscopic residues, lets them dissolve. And the amazing thing, it doesn't seem to damage the artifacts. Sometimes they even look cleaner.
Cleaner, really?
Yeah, the study mentions pigments on pottery might look brighter, or stone pipes just look cleaner. There are minor caveats for really sensitive things maybe, but for sturdy stone pipes that have been buried for millennia, it's not a concern. The artifacts are totally preserved.
That's fantastic. A win for science and preservation. But how do they know what, say, the chemical signature of Nicotiana rustica actually looks like compared to just dirt or background noise? How do they get that baseline fingerprint?
Another crucial piece,
Yeah.
the experimental pipes and quality control. This is fascinating. To get those reliable baselines, the researchers took all those different plants they were interested in, the bearberry, the dogwood, the sumac, all the tobaccos.
The 100 or so potential candidates?
Exactly. And they smoked them in modern clean clay pipes under strict lab conditions. This created a whole library of experimental pipes, each one holding the known specific residue of a single plant.
So they basically built a super detailed chemical ingredient list for every single potential plant by carefully smoking it themselves.
I bet that lab smelled interesting.
Chuckles. One can only imagine.
Wow.
But yes, that's the idea. These experimental pipes with their known signatures allowed for direct comparison to the ancient pipes. It helped them say, yes, these compounds we see in the old pipe definitely match this specific plant we smoked.
Okay, that makes sense. What about quality control?
Right. They also made QC standards. These were mixtures of extracts from different experimental pipes. They ran these QC samples repeatedly alongside the ancient extracts during the analysis. This helps make sure the instruments are running consistently and the complex software analyzing the data isn't making mistakes, like misaligning the chemical peaks. It boosts the reliability hugely. It's like that master chef analogy again. Build the perfect ingredient list for every dish. Then when you find residue in an old pot, you can match it precisely. You know what was cooked, not just guess.
Exactly. It's that level of precision.
Yeah.
And achieving that precision also came down to the analytical tools. They chose liquid chromatography, mass spectrometry, LCMS, over gas chromatography, mass spectrometry, GCMS.
Why LCMS? Was it just newer or better for this specific job?
It was definitely better for this job. LCMS can detect a much wider range of compounds, especially ones that are hard to turn into gas for GCMS, and it's generally way more sensitive.
More sensitive even for things like nicotine.
Yes, the study noted LTMS was better even for common biomarkers like nicotine, caffeine, theobromine. Apparently, GCMS had sensitivity issues before, sometimes missing nicotine where LCMS could clearly find it in the same pipe. Plus, LCMS needed less sample prep and less time on the machine, making it more practical.
So better detection, faster, less work. Sounds like a win-win. And could it tell similar compounds apart?
Absolutely critical point, yes.
Yeah.
LCMS could easily distinguish compounds that might weigh they have the same mass-to-charge ratio, but take different amounts of time to travel through the system, meaning they're chemically distinct. Like telling apart anabasine and nicotine, or theobromine and theophylline. That's what lets you go from a tobacco to this specific kind of tobacco.
Okay. Sophisticated method, precise tools, this amazing library of plant fingerprints, the stage is set. So what did they actually find? What secrets did these ancient pipes finally give up?
All right, so they focused their first analysis on two key pipes from the Pacific Northwest. One was pre-contact, PIAPE 116, really old, about 4,430 years old, dated between roughly 1330 and 1520 AD, found in central Washington state.
Pre-contact, so before major European influence.
Exactly. The other was post-contact, PIPE 108, dating after the late 1700s, also from the Pacific Northwest. This lets you see change over time.
The moment of truth. What was in that pre-contact pipe, the really old one?
Well, first off, nicotine was there. Confirmed. So yes, tobacco was definitely being smoked, just as the old methods might have suggested.
Okay, no huge surprise there.
But the real star, the truly surprising, paradigm-shifting discovery, was overwhelming evidence for Rhus glabra.
Smooth sumac.
Smooth sumac. Wait, that's not tobacco. That's
great.
a common shrub, right? Known for its red berries. What's that doing in an ancient pipe?
Exactly. This was groundbreaking. The first time a non-tobacco plant was definitively ID'd in an archaeological pipe based on this kind of molecular evidence. And it wasn't just a trace amount. They used Venn diagrams to compare compounds. Our glabra shared the most compounds with the pre-contact pipe residue, 45 distinct compounds linked specifically to sumac.
45. Wow. So this was definitely intentional, not just some random contamination from the soil.
Absolutely intentional, a significant ingredient.
Does that match up with anything we know from, like, historical accounts or traditional knowledge? It aligns perfectly. This finding gives solid archaeological proof for long-standing ethnobotanical accounts, records showing indigenous peoples commonly mixed Rhus glabra leaves with tobacco.
Why? What was the purpose?
For several reasons, apparently. For its perceived medicinal qualities, but also simply to improve the flavor and smoothness of the smoke, make it less harsh. So this wasn't just random. It had a documented, purposeful use. And geographically, the pipe was found right where our glabra grows, historically and today. It fits perfectly.
That is incredible. So for centuries, we were maybe missing this whole dimension, thinking it was just tobacco. Finding sumac totally changes the view of these ancient mixtures, maybe deeper medicinal knowledge or just a more refined taste.
It definitely points to a more sophisticated understanding of plant properties than we gave credit for. It's beyond just getting a psychoactive hit. It's holistic. Taste, medicine, maybe ritual significance all rolls into one. Complex mixtures for specific purposes.
Amazing. Okay, what about the tobacco in that pre-contact pipe? Was it local? Imported?
The main tobacco identified was Nicotiana quadrivalvis, Indian tobacco. This native species shared 8 distinct compounds with the pipe residue. Now, here's where it gets really interesting.
Oh, what now?
N. quadrivalvis isn't actually found growing wild in Washington state today where the pipe was excavated.
Whoa, wait. How does that work? A plant not found there now was smoked there over 1,000 years ago. What does that imply?
This is where it really challenges old ideas. Researchers know that Northwest tribes widely cultivated N. quadrivalvis for smoking. Its historical range, possibly pushed northward by human hands, might have once included parts of Washington.
So cultivation, not just wild gathering.
Exactly. It suggests sophisticated cultivation, active management of where plants grew, and potentially even trade or movement of the specific native tobacco across regions. It wasn't just foraging, it hints at early agriculture and exchange networks.
That implies really complex social structures, doesn't it? Trade routes, maybe specialized growers or traders, long before we might have thought.
It absolutely does.
Yeah.
Cultivating a non-native plant requires sustained knowledge, land management, community effort. Moving it requires trade networks, exchange systems. It paints a picture of a much more dynamic, interconnected ancient world than we had direct proof for before. The study suggests the residue might have been a mix N, quadrivalvis, or glabra, maybe other plants smoked together or sequentially. It adds so much richness.
That's a beautiful, complex picture. Deliberate mixtures, ecological knowledge, social networks. Okay. But then history happens. Euro-American contact intensifies after the 1700s. What did they find in the post-contact pipe? Did things change?
Things changed dramatically. In PIP 108, the post-contact one, nicotine was present again. Tobacco use continued. But the type of tobacco had completely flipped.
Flipped how?
This pipe showed compounds overwhelmingly shared with Nicotiana rustica, Aztec tobacco. 5 distinct compounds pointed right at it. And crucially, maybe most strikingly, this pipe shared 0 compounds with N. quadrivalvis, the native species from the older pack.
0, so a total replacement.
A complete turnover in the dominant tobacco.
So after potentially millennia of using native tobacco mixes, there's a sudden shift after contact. Why N. rustica? Where did that come from, and why did it take over in the Pacific Northwest?
N. rustica has its own fascinating journey. It was domesticated way down in South America, long before Columbus. It likely spread northward into eastern North America through pre-contact indigenous trade routes. These existed long before Europeans.
So it was already in North America?
Yes, in the east. Then, after the 1700s, Euro-American traders brought it in bulk to the Northwest. They often preferred it because it was strong. And it seems to have relatively quickly replaced many indigenous tobaccos there.
Interesting. So it wasn't necessarily N. tabacum, the tobacco we think of today from plantations.
Exactly. That's a key finding that challenges a common assumption. Many thought N. tabacum was the main trade tobacco that pushed out native plants. But this study points squarely at N. rustica being dominant in this post-contact pipe.
That is significant. Okay, so why the shift? Was it just easier to get through trade, or was there something else driving people to choose N. rustica over their traditional N. quadrivalvis?
Availability was surely a factor, with new trade routes opening up. But the study suggests something more profound, something deeply human. They proposed the preference shift towards N. rustica was likely driven by its much higher nicotine content.
Potency.
Potency, and therefore, as the paper puts it, more potent addictiveness compared to the native N. quadrivalvis. It's a powerful insight into how new, stronger substances can impact established cultures and preferences. People often gravitate towards things with a bigger kick.
That's a huge aha moment right there. That drive for stronger effects isn't just modern. It was happening way back then, shaping choices, changing ancient practices. It feels like a fundamental part of human behavior with psychoactive stuff.
It really does seem to be a continuous thread. And interestingly, while the main tobacco changed, that post-contact pipe also had signs of the other traditional plants still being used: bearberry, red osier dogwood, and smooth sumac were still present.
So they kept some of the traditional mixer plants.
It seems so. Maybe for flavor, maybe for ritual continuity. So it wasn't a total wipeout of old ways, but a blend, an adaptation integrating the new potent tobacco with some familiar elements.
Okay, let's put this all together. Identifying non-tobacco plants like sumac, finding cultivated native tobacco moved across regions, then this dramatic shift to a more potent trade tobacco. What's the big picture here? This feels like more than just smoking. It's a window into lives, rituals, economies, even desires.
Absolutely. Archaeologically, this method is huge. It lets us identify more plants and, crucially, discriminate use down to the species level. That detail was impossible before. We go from vague tobacco use to specific, chemically proven facts about which species, where they came from, how they were used.
And finding things we didn't even know were there, like the sumac. It validates other kinds of knowledge.
Exactly. This study provides the first solid archaeological chemical proof for using a non-tobacco plant, Rhus glabra, in a pipe. It validates those ethnobotanical accounts, the traditional knowledge passed down orally. It shows those complex mixtures were real sophisticated parts of indigenous practice.
It elevates that traditional knowledge, gives it scientific backing, and the tobacco shift itself tells a story.
A compelling story of evolution. From a native species, N. quadrivalvis, adapted locally, part of specific cultures, maybe even early farming, to an introduced, stronger trade species, N. rustica, becoming preferred, likely for its psychoactive punch. Its cultural change driven by the plants themselves and human desires.
It really makes you question old assumptions about ancient habits being static.
Totally. It highlights complex pre-contact trade networks, then shows how new species disrupted and reshaped those networks and local preferences. And that potency factor, the shift to N. rustica for its nicotine hit, is so significant. It hints at the deep drivers of human choice around psychoactive substances, drivers that seem constant across time. It forces us to ask, how much of what we thought we knew was based on incomplete evidence? This metabolomics approach demands we reevaluate and look for more nuance.
Rewriting history one molecule at a time. So what's the future here? Where does archaeochemistry go with this?
The paper calls it a new frontier in archaeochemistry, offering an unprecedented window into plant use and movement by ancient humans. The potential is vast. Think about applying this to food residues on pots, residues on tools used for making medicines.
Wow, endless possibilities.
Endless. Understanding trade, migration, the origins of farming, ancient medicine, it opens up so many new research avenues into human ingenuity.
That's incredibly exciting, just scratching the surface, really. Now, before we finish, it's worth mentioning the researchers were careful to point out that the chemical signatures from the ancient pipes weren't identical to their clean, lab-smoked experimental pipes, right? There are still complexities.
Yes, absolutely. And that's just good science. They acknowledge that differences are expected due to things like environmental contaminants, leaching in over centuries in the ground, the natural breakdown of chemicals over thousands of years, and even subtle genetic differences between ancient plants and their modern relatives.
So it's not a flaw in the method, just the reality of working with ancient stuff.
Exactly. It just means careful interpretation and ongoing refinement are always part of the process when you're dealing with materials that have weathered millennia.
It is truly remarkable, though. This sophisticated yet gentle science reaching across time to reveal not just if people smoked, but what specific plants they used, and maybe even why those choices changed over time. It brings their world, their knowledge, their cultural shifts to life in such a tangible way.
It really does. A powerful story of science lighting up the past.
And it makes you think, doesn't it, about our own habits today? Right? Think about our choices, the coffee we drink, the foods we crave, the trends we follow. They're shaped by global trade, availability, potency, marketing. This deep dive into ancient pipes, showing that shift towards a stronger, newer tobacco, reveals that these same dynamics, human curiosity, seeking specific effects, the pull of the new, they're ancient, they seem as old as civilization itself. What does that tell you about how little, and maybe how much, human nature really changes over all that time?